And today we're delighted to welcome Enrico Chesta. Now, Enrico joined CERN's Knowledge Transfer Group in 2010 after several years spent in the field of plasma physics at Stanford Plasma Dynamics Laboratory and Advanced Space Propulsion at the European Space Agency and Centre National d'Études Spatiales. So Enrico is currently coordinator of the Aerospace and Environment thematic areas. And in this role, he's in charge of strategic partnerships and initiatives such as the bilateral CERN-ESA cooperation framework and the CERN Innovation Programme for Environmental Applications. Enrico, please do take it away.
Welcome to this session about news from the lab. I'm going to talk to you about two different topics, aerospace and environmental applications. They are independent topics, but there is some overlap. There are some links, and this is one of the reasons for it makes sense to present them together. And the other reason being that I happen to coordinate both of them within the knowledge transfer group at CERN. So as you might be already aware, the knowledge transfer group is the unit within our organization, within CERN, that looks for technologies, facilities, or more in general know-how from our experts that can find applications in other areas than high energy physics. And we have five main areas of focus: aerospace, environment, healthcare, quantum, and digital. So I understand that healthcare was already covered, I think, in January by my colleague Ben, and later in May, September, there will be also colleagues talking about digital and quantum applications. So really the focus tonight is aerospace and environmental applications. Just to make sure that you are aware about the activities of the group at large, we have just published a little brochure, the KT highlights, that shows the results, the most important results we achieved last year. You can download it from our website if you're interested. It shows a little bit what we are doing, like in numbers. So you can see last year we had about 10 new technologies that were disclosed, or 11 that were disclosed, some 40 contracts that were signed in different fields, about half of them with industry and half with laboratories or research centers. And some of these contracts are generating revenues, and the revenues that are generated, part of it goes to cover the costs that the organization has incurred in doing collaborations with the partners. Part of it goes to the KT Fund, which is an internal tool that we use to fund new projects every year. And last year, we managed to fund up to 1.5 almost million Swiss francs of projects, many of them in the field of environment. And I will tell you more about it. So these are the general activities from KT. Now, let's start focusing on aerospace. And just for your understanding, in historical terms, CERN has been active in medical applications since ever. We have been focusing on aerospace applications a few years ago. Now I've been working on it for about 5-6 years, maybe even a little bit longer. While environmental applications is something relatively new, relatively recent, we've been focusing on environment starting from last year, even though now it is quite a priority. In aerospace, I can already share with you some results achieved in the recent past. But first of all, the reason for we are doing and we are focusing on aerospace applications, but there are many reasons, not only because for me it's a passion, as you could learn from my small bio, I'm an aerospace engineer as a background. I've been working several years for the European Space Agency and the French Space Agency before joining CERN more than 12 years ago. But apart from my personal passion, the reason for we are focusing on aerospace is that there are some important new trends in the economy that are of high interest for many of our member states, many industrial players in our member states. One example is the new space revolution, which is basically the easier access to space that is possible thanks to a lower cost of launchers. There are new launcher technologies, in particular reusable launchers like those of SpaceX that has considerably lowered the cost of putting payload in space, and this has opened paved the way to constellation of satellites, of small satellites, mostly cheap satellites, targeting performances rather than reliability. And this is a completely game changer in the space sector, and many new industrial players are investing efforts and means into this sector now, and this is why it is relevant for our member states. And then another important trend is the one of clean aviation. Even though here is the overlap between aerospace and environmental applications, I will speak more about it in the frame of the environmental application presentation we'll give later, but it is clearly a priority for everybody. But apart from that, there are a lot of societal impacts that can be addressed by aerospace applications, ranging from environmental monitoring, again, to telecommunication, transportation, especially long-distance transportation, exploration. And even more, as you probably know, we are trying to see if we can support our neighboring scientific fields, astroparticle physics in particular, multi-messenger astronomy, nuclear physics, and many scientific missions, especially for astroparticle physics, are space-based, and so we can support them technologically through our developments, because this is what we are doing. Just a quick glance on, let's say, the statistics. This is extracted from a brochure that we published in 2021, looks like that, can also be downloaded from our website. But in 2021, just give you an order of magnitude, we have some 17 technologies flying or about to be integrated into space missions. About 30 collaborations, partnerships with industries, with agencies related to space projects, and more than 30 students involved in space educational projects. So these are just some statistics to give you an idea of the critical mass we are reaching in aerospace applications, at the point that CERN is being considered now as a serious player in a field which is considered quite conservative. So it's not easy to be credible in aerospace. We are getting there. And we're getting there because there are some natural synergies between what we are doing at CERN and what is being done and is needed in aerospace. The areas or field of expertise that are listed on the right are there where the synergies are the stronger. And if I had to mention one, radiations. So not everybody is aware that the radiation environment that you can find in low Earth orbit is quite close to the radiation environment we can find in our accelerators. Not really in the detectors, where the radiations are usually higher, but in the accelerators and in low Earth orbit, they're comparable. And this is a strong natural synergy, and many of the projects I will describe are related to that, but they are not the only ones. There are also synergies related to the vacuum conditions, to the extreme temperatures from very cold to very hot that you can find in space. And of course, reliability. Reliability is an issue for satellites, probably even more than for accelerators. So I will go now through these different topics, highlighting what we can do for space, what I've been doing in the recent past, also highlighting some of the recent success stories, and starting, as mentioned, by the field of radiations, especially radiation monitoring, dosimetry, and space weather in general, because this is really the area where, the links are strongest. So let's start from an example that I like very much, is the Space Radmon. And this is a radiation monitoring instruments, low cost, entirely based on components of the shells, like RADFETs, memories, pin diodes, that are used to monitor the effects of radiations on electronics. And this is an instrument that was developed for the LHC and is deployed in large numbers in the LHC, but we made a smaller version, lighter version, less power consuming version that can be used on CubeSats, on small satellites. So the Space Radmon is very light, about 50 grams, doesn't consume a lot of power, and it's an instrument that is perfectly suited for low-cost missions. And so we started this development through a KT Fund project. So it was funded by KT. And the main most visible achievement is the launch of Celesta, which is quite a unique mission from many different points of view. It's a first of a kind because it's the first time, we can call it the first CERN technology demonstrator in space. So we've been flying several technologies in different satellites, but this is the first time that one satellite is entirely dedicated to one of our technologies. And it was a technology demonstrator in the sense that we wanted to show that our Space Radmon technology could fly in space. And so it was the first time that it was flight tested, our instrument. It was also the first time that we were testing in our irradiation facility CHARM a full satellite. So this was the idea of proposing system-level testing for satellites, showing that we can reproduce in our aviation facilities conditions that the satellites can find in orbit. And so we can save a lot of money by testing the whole system. So there was a radiation model of the satellite that was tested in CHARM, and the mission was launched last year. It was July 13, 2022. This is a collaboration with the University of Montpellier and the European Space Agency. The University of Montpellier put a lot of students working on this project, and they also gave us their Robusta platform for the satellite. We provided the payload, the instrument, and ESA offered us the launch. We had to wait a little bit for it because they thought that this was a good mission to be launched with Vega C. It was actually an upgraded version of the Vega launcher that had some problems in the recent past, so it was delayed by several years. We started working on this project in 2014, so it took almost 10 years with the support of many departments from CERN. At the beginning, it was the engineering department, but also systems now and beams were involved, and the radiation to electronics project. So at the end, the satellite was launched, and it was not put in a normal traditional low Earth orbit, which is about 600-700 kilometers. It was way higher. It put it in at 6,000 kilometers, which is a very high orbit, which in terms of radiation is not bad in the sense it's in the very middle of the proton belt, of the Van Allen belt around the Earth. This is a place where usually satellites don't want to be. But the main payload, the launcher, was a satellite that was completely covered with mirrors, with no electronics, so it didn't care about radiations. While we were looking for radiations because we wanted to show that we could collect all the statistics. So to make it short, in 3 months, we collected all the statistics we were planning to collect in 1 year, and the mission was considered a success. Now, hopefully, we'll be able to showcase the qualification model of Celesta in the Science Gateway when it will open. In any case, the flight model of Celesta will fly at 6,000 kilometers for centuries. Actually, I think somebody calculated it would take about 20,000 years before it comes, it will re-enter in the atmosphere. So it will be a long-lasting experience, and I don't know what CERN will be in 20,000 years from now, but Celesta will still be there and flying. So I need to accelerate a little bit because time is short, but I also want to give you other examples like, TimePix is an important example. TimePix is a detector developed in the frame of the Medipix collaboration. It has been the single technology from CERN that has been flying the most. Many satellites from ESA and especially from NASA have been using TimePix for dosimetry. It has been flying international space stations, many units, on the Proba-V satellites from ESA, and NASA has been flying it or selecting it to fly for in the last 10 years many times, and they are planning to fly in the next 10 years again, and especially for the Artemis mission to the moon. And that was one of the highlights from last year, because in November Artemis 1 was launched, and there were some Timepeaks units on board the Orion spacecraft that went around the moon and then came back on the Earth in December. But there was also one Timepeaks on the BioSentinel mission that was on board Artemis, but didn't go around the moon. It was sent in deep space, and this will be the single piece of CERN technology that will go the farthest away from CERN, because eventually it will reach some 60 million kilometers from the Earth. So in terms of technology transfer, this is very symbolic. It's a mesh to transfer it very far away. So this is another good example of technology from CERN that is serving aerospace. Then staying in the field of radiation monitoring, in 2021, so a couple of years ago, Thomas Pesquet, in his last mission, started a specific instrument called Lumina that was, it still is an optical fiber that is used to measure radiations on the International Space Station on large distances in a distributed way. And this instrument was calibrated at CERN, and CERN was strongly involved also in the interpretation of the results. This mission will last for at least 5 years. And then last example of radiation monitoring for space. In this case, it didn't go to space. It just went on the top of the Matterhorn. This was the Chrome instrument that was deployed in collaboration with the Swiss Space Center through the Igluna project on the mountains, just to show that actually there is a cavern up there close to Zermatt on the top of the Matterhorn, and you can basically put a radiation monitor inside and outside the cavern and understand what is the shielding effect of ice that could be useful for future human missions to the moon. And yeah, actually, since we are talking again about the moon, actually NASA might send on the surface of the moon a Timepeaks this year through the Peregrine mission, and it might be an highlight for this year. So this gives you an idea of what we are doing in space in the field of radiation monitoring. Then other examples concern radiation hard electronics. Several devices from CERN are of interest for aerospace, from DC-DC converters to silicon photonics, even some sensors, the Altai sensors that might be used, that will be used in the next Chinese mission to study the earthquake signature on the ionosphere. The scientific mission should be launched this year or next in collaboration with the Italian Space Agency. So radiation hard electronics is quite relevant, and radiation tolerant systems, which are basically complex systems made of several components that do not necessarily need to be radiation hard, but they want to be as radiation tolerant as possible. And we can test them in our facilities to make sure we select the components that behave the best, that have the best performances. And this is actually a nice way to collaborate with industry, with new space companies that are trying to develop compact, low-cost instruments. They come to CERN, they test their systems, and we can help them optimizing their systems. This is a quite successful way of collaborating with companies. In these images, you have different kinds of systems, from cameras to onboard computers. There's quite a lot of variety in this field. Then this is another highlight from last year. We we manufactured, built, and tested the first demonstrator for a high temperature superconducting magnet that could be used in space. This was done in collaboration with the Italian Space Agency and with INFN in TIF. But this is a project that lasted a few years and is an important milestone because, as you probably know, there has never been a superconducting magnet that has been launched to space. And this technology is very useful for high-resolution astroparticle spectrometry. It might even be considered for shielding astronauts for long distance missions like to Mars. And so the main application and the application for this coil has been developed is really astroparticle physics. Then other examples, thermal management through, for instance, silicon micro oscillating heat pipes or micro channel for cooling of electronics, or 3D printing, for instance, for RF loads that are used for telecom satellites. Software tools and in general, IT is very relevant for space applications. These are some examples. CERN VMFS, this is a tool from CERN that has been deployed in the ground segment of Euclid, the scientific mission from ESA. Euclid is the scientific mission from ESA that will generate the highest amount of data, and they've been relying on CERN for this software, which is really needed, and actually it will be used probably in the second half of this year, because Euclid will be launched in July, if everything goes fine. Giant4 has been used for simulation, for instance, for LISA mission, and MoldFlow for vacuum simulations, also for LISA, but also for other NASA missions, in particular SphereX Mars 2020. And also, when we talk about IT, we should not forget long-standing collaborations like the one that CERN has been having with UNOSAT since many years, by using CERN computing infrastructure to help UNOSAT analyzing the images from Earth observation satellites that are used for humanitarian missions mainly. And also a recent collaboration that we have set up with ESA to use artificial intelligence and quantum computing again for analyzing Earth observation images. And there are other projects coming that we mentioned in the second part of this talk about environmental applications. Then I would quickly like to go through the irradiation facilities we have at CERN, because they are very relevant for aerospace. I already talked about CHARM. CHARM is our high energy accelerator mixed fields facility, where we can test at system level complex systems, and where whole satellites, actually systems as big as a fridge, can go and be tested all together. Celesta went there, and this is a facility which is considered by ESA for testing their satellites, and can also be used for screening batches of COTS, for instance. And we are working on an upgrade of this facility called Chimera, that will make possible to have high energy, heavy ions, high penetration irradiation tests in CHARM. This is what was done before, maybe it's still done now, but in the future will be done in CHARM. But in the past was done in the North area. And these were many missions for astroparticle physics went through, starting from AMS, but also HERD. And where we tested, for instance, in the past, the artificial intelligence chip from Intel that is flying on a FISAT mission from ESA to analyze in orbit Earth observation images. And then another facility which is quite relevant is VESPER, part of CLEAR, because here we can accelerate at very high energies electrons and simulate the environment that satellites can find, for instance, around Jupiter. And Jupiter is a very strong magnetic field, and you can find electrons there that goes up to several hundred megaelectron volt. And the only place where you can test the electronics of missions like JUICE that are planning to go there on Earth is at CERN in VESPER. So we did it. It was 2018. It was a very nice collaboration again with ESA and the JUICE mission. They were quite happy, and if I'm not wrong, JUICE is expected to be launched the next week or in a couple of weeks, mid of April. So hopefully you will hear about it very soon again, and hopefully when it will get to Jupiter, it will be safe thanks to the test they made in our facility. And okay, we should also mention the CryLab. That's not radiations anymore. This is more about testing in cryogenic conditions, instruments that should operate at very low temperatures. And this is the list of the CERN recognized experiments which are actually space missions, flying in space. So space missions for science that are supported by CERN because their scientific purpose is close to our targets. There are about 10 of them, and the most important and famous is AMS. That was integrated, calibrated at CERN, and it is operated by CERN. So the payload operational center is in Prevessin. But every mission is different, so all of them have been supported at different levels. Take, for instance, Euclid is one of the last that were recognized. As I mentioned, it was supported through software deployment in the ground segment. And there are also European projects where CERN is involved that are used for aerospace applications. Some of them are related to radiations, RadSAG, RadNext, and more recently HERTZ. HERTZ is the project that will complete Chimera developments that was sponsored by ESA in order to have this facility in Europe for making high penetration tests, while before we had to go to the United States, basically, and a few others. Also, to give you an overview, we have collaborations mostly in our member states, but crossing the borders to the United States and in China and beyond. So we really have collaborations everywhere. Even to the most important framework cooperation we are implementing since many years now is the one of the European Space Agency. And this is the one that is also generating regularly contracts where ESA is sponsoring projects through financial support that are carried out at CERN. So this is the short overview of CERN Aerospace Applications. Once again, we have published this brochure if you want to know more, and there is more information on the website that we try to keep updated. Now, if you agree, I'd like to move to the other topic, which is environmental applications. So as I mentioned at the beginning, this is more recent in the sense that we started as KT trying to coordinate the efforts of the organization in implementing environmental application projects 1 year and a half ago. And the reason for environmental applications are a priority for CERN now more than ever are quite obvious, to be honest. Nobody is questioning anymore the importance of environmental applications at the moment. So there is a raising awareness on climate change, causes and consequences. There's a sharp increase in the energy cost, especially due to the current geopolitical situation. And there is also growing importance of clean tech innovation in the industry in the member states. So if you want to show that we support industries in the member states, we want to be active in the field of clean tech. So this is why there are several actions that were identified by the management as main objectives for organizations, the Horizon 2025. Some of them are about minimizing the negative impact of the lab on the environment. Many of them are about saving energy and cost, but also there is this strong effort in trying to identify technologies that we are developing for CERN and that can be used also out there by other partners to have an impact on the environment on a global scale, so beyond CERN borders. This is why we defined a high-level strategy for environmental applications. So we found that the 4 areas are quite large that again have the strongest synergies with certain technologies and know-how are the ones shown in this plot. So renewable and low carbon energy, production, transformation, distribution and storage, clean transportation and future mobility through all the means, aviation, shipping, rail, automotive, climate change and pollution control, at the same time monitoring, modeling and mitigation actions, and then sustainability and green science, for instance, power management, heat management, or industrial processes. And in these areas, there are quite interesting, solid, strong links with the CERN know-how that we have. And I have some examples because we are starting implementing projects. So these are all highlights from last year. We had a collaboration with EP+, which is a lab in Spain, where they are developing testing facilities to help developing composite tanks for hydrogen storage. And we help them with the design of a cryostat for doing mechanical tests in cryogenic conditions. Then Airbus, this is one of the most important highlights, and I have a slide dedicated to that afterwards, so I skip it now. Isa already mentioned this project with Philab to develop artificial intelligence algorithms to analyze Earth observation images. And ABB, that's a collaboration to deploy sensors that combined with digital twins can improve energy efficiency of our cooling and ventilation systems by a considerable percentage, I think 15% gains. And in particular, if you want to mention one important highlight, this is the collaboration with Airbus. So the idea is that in the future, Airbus will fly airplanes, will develop airplanes that will use hydrogen as a main propellant. Hydrogen, if you want to store hydrogen at high density, you want to have it liquid, but hydrogen is liquid at 20 Kelvin. So if you have a coolant source at that temperature on the plane, then you can seriously consider having superconducting power distribution, especially if you use the hydrogen in fuel cells that will supply energy to the engines, which are not necessarily located close to the fuel cells. So for all these reasons, it makes sense to evaluate at least the possibility of having onboard superconducting power distribution. Now, it's not obvious that all the advantages will be there. There are also considerations related to the reliability and safety of the systems that need to be taken into account. So this is why Airbus is building a demonstrator at Airbus premises, and we are also building a demonstrator that we call Scale Superconductors for Aviation with Low Emissions here at CERN, where we hope to be able to show to Airbus that the adaptation of the technologies that were developed at CERN for their planes will make them gain a lot in terms of mass savings mostly, but also cost savings, because the core technology is ready and we are using it. Then these are the projects that we are implementing that have already been signed, so we can talk about them freely. There are others that are in pipeline but are not signed yet, so I cannot disclose too much information about them. But one important initiative that we have launched last year is the CIPEA, the CERN Innovation Programme on Environmental Applications. That was a call to new ideas that was open to the CERN community. There was a kickoff event organized in March last year and an innovation event in June. In between, there was a long brainstorming phase where the CERN experts came with ideas showing that what they are doing, what in their daily tasks could have applications for the environment. And then we, after this brainstorming session, brainstorming phase, we came with some 15 proposals that were formally submitted, which means with the approval of the management of the hierarchy up to the head of the department level. And those 15 ideas were presented and discussed during the Innovation Day in June. And at the moment, there are at least 8 projects which are being implemented, most of them also through KT funding, but some of them through external partnerships. Here's the list. So you have the list of the projects that we are currently implementing. These are the little logos associated to the project that was submitted. And maybe I can say a few words about one of them because we just signed the agreement. It's the last one, the EVAC-RED, the insulation vacuum of superconducting cables for renewable energy distribution. This is a project that will be done in partnership with Supernode, which is a company located in Ireland that is developing a technology to deploy superconducting cables for grid applications over long distances, including under the water on the bottom of the oceans. and they were looking for help from CERN to develop the vacuum layer of insulation that will keep the superconducting cable at superconducting temperature. And so we will develop some testing benches, testing facilities that will allow making measurements on their samples, that we provide them with the parameters needed for optimizing, completing the Kronstadt design they're doing. But that's a nice example. Now, more in general, if we put together all the different ideas that we have been discussing with CERN experts, all the different requests we are receiving from companies that contact us on a daily basis, also the inputs that we are collecting from our member states, that we meet once a year at least with what we call the KT Forum, with delegates from the member states that tell us what their priorities are, and more in general, trying to see what the technology trends are in the clean tech areas, putting all together and trying to see what are the CERN assets that can contribute to play an important role in there. We have hubs of experts with critical know-how. Sometimes we have unique facilities. Sometimes we have relevant intellectual property like patents or a specific design which are not in the public domain. So putting all together, we have identified about 20 pools of competence. These are how we call them in our environmental applications, where we could play a significant role. And we have been asked by the management to make a ranking in order to better focus our efforts. So we applied some kind of ranking based on quantitative and qualitative criteria, number of running projects and preparation, industry needs, impact potential. That is obviously qualitative but important. So we came up with a list of 8 posts of competences that we believe should be our priority for the next few years. And these are the ones listed here in this little table. And these are really the areas where we would like to focus, and where we are collecting also inputs. So also is an important message for the alumni network. If there is anybody who is somehow working or active in these fields and would like to establish collaborations with CERN, these are really the areas where we would like to be contacted for. I can say maybe if some time, I can say a few words about these different areas. The first one is compact magnetic confinement fusion energy systems. So as you probably know, CERN has been collaborating with ITER for many years. We have been, I think, we have 24 collaboration agreements with ITER. We've been really supporting them from many different points of view. There are key competences in high-effect magnets, both low temperature, high temperature, quench protection systems, data acquisition, time synchronization, White Rabbit in particular, diagnostic systems, radiation tolerance on materials, on electronics. So a lot of the things we are doing at CERN are important for fusion initiatives. And now at the moment, there are many private companies that are raising amazing amount of money to develop compact, especially magnetic confinement, not only magnetic confinement, to be honest, also other types of confinement are considered. But the fact is that there is a lot of investment at the moment in the field in order to bring fusion energy on the market on a relatively short timeline, say 10 years. We're not talking about 20 years anymore now, it's more about 10 years. So many of those private companies have actually contacted CERN hoping to get some kind of support, and we do have expertise that could be relevant. So we would like to define a strategy to see what are the initiatives that we can support, that we should support, in which way. So it's clearly a field where we will be active in the near future. Then the other one related to energy generation is accelerator-driven systems, accelerator-driven, but also in general advanced nuclear reactors. So these are all those advanced concepts where for instance, in terms of the ADS, where the nuclear reactor is subcritical and is driven by an external accelerator. And here we have competence in accelerators, but also in beam windows, in cooling systems based on heavy liquid metals like lead or lead bismuth. And also in this case, we are collaborating on an institutional level with MIR, that is the institutional project is trying to show the feasibility of this technology, but there are many private initiatives at the moment which are running, and more in general, we could contribute to all those initiatives that are trying to bring on the market small compact nuclear reactors generation 4, especially if they are cooled with technologies that are compatible with what we are needing, for instance, for our muon collider or for other fixed target experiments. So these are two areas. Of course, there are other poles of competence related to energy generation, including wind power, solar power, photovoltaic. We do have ideas, but these are really those where the two where we are to focus because the synergies are the strongest. Then I mentioned examples, Airbus and Supernode. They are related to superconducting lines. So Airbus is an example of a superconducting lines for onboard applications. Supernode was an example of a superconducting line for grid power distribution. In both cases, we can do a lot. We are doing a lot. We can do more, and we are interested in learning more. In principle, onboard superconducting power distribution systems could be applicable to any kind of means of transportations, including planes of different sizes, ships, trains, trucks, probably less so for cars, but you never know. And then power distribution data centers, advanced grids should be investigated. And then I mentioned already liquid hydrogen. So yes, liquid hydrogen is used in future planes from Airbus, but more in general, all the member states from CERN are developing national strategies related to hydrogen. It's really considered a key to achieve decarbonization in the future. And AP Plus is an example, but we are talking with several actors in the field because it's not trivial to handle hydrogen at 20 Kelvin, and we do have competences at CERN since we are playing with liquid helium. We know how to handle leakages, we know how to handle materials behaviors at those temperatures. We know how to make measurements in those conditions, and not everybody know how to do it. So some competence in this field are quite well, are often required, and they could really help this sector of the economy, which is really growing. Then I mentioned instruments and facilities for remote and in-situ environmental monitoring. Well, we put here at the same time detectors, sensors that can be used in situ for measuring, for instance, the parameters of the soil from the humidity to well, any kind of parameter that can be relevant for agriculture or for feeding models of long-term climate simulations. And some of our technologies can be used locally on the ground or maybe on the air. We have also examples of technology sensors that are used to monitor the quality of the air. But we include here also instruments that can be used for remote sensing from satellites. And once again, what we can do in our facilities, like in CHARM, to optimize compact instruments for Earth observation monitoring missions is very important, and we should do more and more in this field. Then artificial intelligence platform for global phenomena modeling, climate simulations. I mentioned the collaboration with ESA. There was also a EU project InterTwin that will develop technology will be very relevant for this. And in the frame of CIPEA also, we had a very interesting proposal that will develop a project which is actually starting only now. So you will hopefully hear about it more in the future. And then last, the green science and sustainability pillar, these all technologies can also be used by CERN itself to reduce its negative carbon footprint. So in terms of engineering system optimized for low emissions and energy efficiency, there are a lot of examples we can do, ranging from the CO2 cooling to high efficiency clystrons to many CIPEA projects that were proposed, for instance, to develop magnetrons technologies that could be applicable also to reduce industrial electric heating. We have many examples in this field. And last but not least, computing fast, low power compute techniques that could be based on artificial intelligence. But I think this is a topic we've addressed by my colleague Nick doing next seminar about digital from KT. So I'd like to finish here my presentation. But at least we have 15 minutes for questions. If you want to know more about environmental applications, we are updating now our website. Feel free to have a look, and of course, feel free to contact me now or in the future if you have any questions. Thank you.
Fantastic. Thank you very much, Enrico. That was a fascinating talk on two very relevant topics. And I was able to see that in the audience, we have alumni who are actually working in those two domains, which is great. So maybe I could start with a quick question, if that's okay. You mentioned earlier that you were keen to maybe identify companies that perhaps would be willing to investigate possible synergies. So if we have any alumni who are here today or who are watching the video, what would be the preliminary steps for them if they were interested in looking further with you?
Contacting me. That's
okay.
That's the easy answer, in the sense that okay, every case is different. I've been working in KT now for 12 years, and really it's difficult to define general rules. Depends very much on the kind of collaboration they could be targeting. But let's say if there is, for instance, one alumni that is working on a company that is active in clean tech, and he or she believes that we are doing things at CERN that could be relevant for what he or she is doing now in their new company. Well, let's talk. Let's talk and see how we can build. So we are trying. So last year we organized this CIPEA initiative where there were several external organizations already involved. This year we will not organize an open call for innovation, but will be once again a selection of projects that can also be funded. So this KT Fund tool is very important, and usually the funding session takes place in September, October. So between now and then, we are collecting new ideas and shaping projects that will be eligible potentially to be funded by then. So it's a good timing to contact me or to contacting us. We're a team, many people working on this, but please don't hesitate.
Great. So we've got your email address here in the final slide. So everybody, please do contact Enrico in that case. Now I'll pass over to the audience. I'm wondering if we've got any questions in the chat. I haven't seen any, but perhaps somebody would like to come on camera and ask their question.
Yeah, thanks a lot, Enrico and Rachel, for this. That was really interesting. Just to say quickly, so I'm an Atlas physicist who is investigating various ideas to join this environmental industry that's growing now. So I'm doing an MBA now in EDEC in France, with an idea of that working afterwards in sustainability. I'm also investigating the idea of creating a company afterwards, post-MBA. So I just joined an incubator in Berlin, which is focused around climate and climate impact. So this called Carbon 13. And I'm also doing entrepreneurship track within an MBA with an idea studying. So I'm really interested in what you mentioned about the fusion energy space, in particular diagnostics and things related to, let's say, what a particle physicist like me is familiar with. So it'll be very interesting to maybe hear a little bit more if you have time now, and also for conversation afterwards, just to mention what type of things you think could be good collaborations for these private fusion companies.
Yes, the topic is really exciting, to be honest. Fusion, I mean, and I think what is really making a change, if my understanding is correct, is that there is a decreasing in the price of high temperature superconductors that at the moment are being more and more considered for being deployed to achieve very high fields in a compact way. So achieving what was not possible when big projects like ITER were conceived many years ago. So this is opening really a lot of possibilities, and investors are believing in that. So the availability of money and the availability of technology combined can really make amazing things possible. So there are several initiatives in Europe and more in the United States that are going this direction. Let's say we are at the moment we are talking with everybody, and we are collecting inputs to understand what the different needs are. So we are aware of interesting initiatives. For instance, there is one consortium of companies called Gauss Fusion that is taking speed. There is in the United States Commonwealth Fusion Systems that is doing giant steps in collaboration also with some partners and member states like ENI. There is in the UK, we had a long-standing collaboration with Tokamak Energy. For instance, for them, we did some quench propagation simulations using our software tools, and we tested a couple of years ago a coil magnets up to some 26 Tesla, which was a very high level for the time, and we were quite happy. And they are collaborating also with the UK Atomic Energy Agency that is working on the STEP project. So there are many projects ongoing, and also there are some more exotic solutions. There is a Renaissance Fusion in France that is trying to optimize stellarator concepts, which are different from tokamak, but they're still based on magnetic confinement. There is a General Fusion in Canada, but with connections in the UK, which is also trying to develop quite interesting technologies in the field. The Marvel Fusion that is more working on laser, but yes, some connections. So there are really a lot of initiatives, and okay, difficult to go through all of them at the moment. But if you're interested, maybe we can have let's say separate talk. Don't hesitate to give me your contact details. We can discuss this later.
Okay, sounds great. Yeah, I mean, it's very interesting indeed also that somehow, as you said, that there's also private investors investing more now than government funds around the world. Okay, I'll shoot you an email. Maybe we can have a follow-up chat.
Don't hesitate.
Wonderful. Thank you very much. Now let's see, Stefania, would you like to try again to come on camera and put your mic on, see if it works?
Camera works, I guess. Mic?
Yeah. Perfect.
Video.
All right. So I also posted in the chat, but then I will basically almost read it out loud. So in the given the recent changes in the aerospace system, actors, market, and things such as the commercial applications we might have, the other actors other than agencies, we are going to the moon to remain, we are building human presence there in order to go to Mars and things like that, CubeSats and so on and so forth. So you know better than me the changes to the system there. What would be the best CERN technologies to have there? So what would be the added value of having a close ESA CERN collaboration for that? Well, ESA because of European, but I mean, I assume that it would be also a close CERN ESA or other actors there. So what would be my question? Well, what would be, in your opinion, among all the technologies that you listed, the best or the most useful, given the changes to the system?
Thanks for your question. It's not only my opinion. Actually, we have signed a cooperation agreement with the European Space Agency, I think 9 years ago. And in that initial cooperation framework, we identified some 10, 12 different areas of possible collaboration. And we've been exploring them more or less systematically, but the one that clearly generated the biggest satisfaction from both sides is everything which is related to radiation. So radiation monitoring on one side, and I had some examples in my presentation about all these missions that are used to monitor radiation in space, but also radiation testing that is used to improve electronics or to select better performing equipments, and radiation shielding that is necessary for protecting the astronauts on the ISS and beyond. So everything which is related to radiations is today very important, and I can only expect it will grow in the future, especially because we are working, and I briefly mentioned it, but it's important to repeat it, on a facility which is called CIPEA, that might be the first ESA recognized facility based at CERN, open also to external users. This means that if there are aerospace companies that needs to have high penetration tests on their complex electronic systems very deep, they can come at CERN, having them tested at CERN, and get the stamp of qualified technology from ESA. So that will open a lot of possibilities, and hopefully this facility will be available starting from the end of this year for, let's say, for calibration purposes, but the end of next year for real running tests for external users.
Thank you very much, Stefania. We also have, perhaps, do you have time for one last question? We have Maria who's raised her hand. So Maria, please, if you'd like to come on camera and also on mic, go ahead and ask your question. Hi.
Hello. Just a short question, and I think you already mentioned before. Will there be a new meeting of the CIPEA project?
The question is, will there be a new
meeting?
A new meeting. Okay,
yes,
we would like.
Thanks
for the question. We would like to organize probably after the summer one event where we will present the outcomes of the project we selected last year, and in the meanwhile, again, we'll collect inputs in order to get new projects running. And maybe we will launch a new CIPEA initiative in the next year or the following one. But now, let's say we have, thanks to the first CIPEA initiative, we have understood that there are competences at CERN, there is willingness to contribute to different projects. And now we would really like to work on this concept, the poles of competence on environmental applications. And the CIPEA was a way of feeding them, but we need now at this stage, especially contacts with external players that will share with us their needs so that we can build with them high-profile projects that can get visibility on the long run. But yes, there will be at least one event short of the summer and before the next KT Fund selection, we will present the outcomes of the CIPEA projects we are implementing now.
Okay, thank you very much.
Thank you.
And just a question from me, Enrico, if I may, would this be an event that also CERN alumni are able to take part in, or is it mainly restricted to internally at CERN?
I don't think this has been discussed yet, but I see no reason for this should not be open to alumni, on the contrary.
Okay, great. Well, we'll make sure that we publicize that to everybody in our alumni network. So that is absolutely perfect timing, Enrico. Thank you so much. And thank you for also, thank you for this really great presentation for all of those who joined us today. And once again, Enrico, many, many, many thanks. And also thanks to everybody else for joining.